platforms from day one. And in total, we've published to pretty much every smart TV app platform out there. We've published to Samsung, to Vizio, to LG, to Yahoo Widgets, to even Google TV, and we've recently started developing to Boxy. We're very interested in the opportunity to bring over-the-top services to the television, and we're also interested in how those over-the-top services dovetail with broadcast content. We're going to get into the framework that we're using to approach that. Fundamentally, we want to extend the investments that have been made by the TV manufacturers and add some capability that will make this a really exciting marketplace for developers and for the media companies that are already on television. Some of our other partners, we work with media companies like Warner Brothers, CBS, Fox, web video properties, musicians, to basically help them reach the smart TV. In total, we've developed over 70 smart TV applications on the most popular TV app platforms. I'm not actually here to talk about this, though, and if you have any questions about our experiences here, we'd be happy to take those when we get into the Q&A. We're actually here to talk about the things that we felt were missing in the smart TV app platform and the things that we built to kind of complement the TV app platforms that are out there. The first thing that we noticed was that the apps themselves are not unlike TV channels, meaning that some media company has decided what's going to be inside each of those branded applications in the App Store. And some editorial effort exists to keep that content fresh and exciting for the users of those apps. But there's no way that those apps can be a perfect reflection of what you care about and the things that you want. So we started an open source project. It's something that we publish and discuss on a website called flingo.org. So those of you who are online or now or later could come and check this out. And the notion is simple. If you find something on the web, fling it to your TV if you want to watch it there. And we support a number of major web video properties to do this. I'll just do a quick demo video here. So this user has found a video on YouTube that he or she is really interested in watching on TV. The user's installed our bookmarklet, which is right here. And when you fling that video using that bookmarklet, it's now playing back on your TV. So I'm going to go ahead and just do a live demo of this. I'm on flingo.org. I'm going to drag this bookmarklet up to my bookmarks bar. The TV app platform that we're using to demonstrate this is actually the Netgear Neotv. It's a new set-top box. It's selling really well in most of the major retailers. It's a sub-$100 over-the-top streaming box. I think the price is around $70 at retail right now. It has about, I think, well over 100 apps. One of the apps is an app called the Flingo. So if I find a video that I like to watch, I'm just going to YouTube here, and I'm going to go ahead and type in CES. And it looks like we've got a video from Gary Shapiro. Or no, this might be the Paul Jacobs from Qualcomm. If I'd like to watch this on my TV, it's one-click operation from the browser to fling that up to the TV here. What does that say? Is this demo not going to work? All right. Okay, this demo is not going to work today. What we're going to, you'll have to take my word for it, that basically that video is going to end up right here on this TV if they were on the same network. And the reason that we use the network, the local area network, is this introductory service, is that for services like DLNA, it's really interesting for people that have content stored on their hard drives to be able to play it on their TVs. But DLNA doesn't apply to the cloud. And we wanted to build an open source project that would allow content that's on YouTube and other popular websites to be played on your TV. And that's an interesting complement to what's already happened in the smart TV market. I'm going to turn it over to Dave Harrison, my CTO, who is going to explain a little bit about how you can include Fling in your products. Again, this is an open source project. You can go to flingo.org and get some instructions on how to do this.
Okay. In order to make it as easy as possible to Fling, I wanted to start from the assumptions that it must operate within the constraints imposed by a web security sandbox, okay? Which means you're constrained to same origin policy unless you use cross-site scripting, and you don't have access to multicast or broadcast in order to use Bonjour or any other kind of discovery protocol. So what was the minimum thing that you can do that would actually allow you to Fling from a web page? Well, if you're willing to use web services to do this, to do the introduction, then you can actually reduce it down to a single link. And I have an example here of where I have actually added this link. There's no changes to YouTube here except for that I added a link into this description. And the mere fact that this link is on this page is going to make it possible for me to Fling it to the TV. When I click on it, it's telling our back end, we have discovered no Fling-enabled devices because this is on a separate network. But what it does in our back end is it actually compares, or it pairs the Flinger to the television and will Fling the video across. The other aspect of the fact that I'm using a link is that a link is ubiquitous, meaning that I can put it in any web page. I can send a link to a friend in a chat window or an email or post it on a blog, and when they receive this link, if they're at home, they click on it, it will Fling it to their TV in their home. Okay. I'll just send that back to you.
So any questions about Fling? Are there any mobile app developers in the room that are interested in how you could include this? Yeah. Yeah, it's a good question. Does your neighbor have access to your Wi-Fi network? No, not at all. Basically, similar to DLNA and other technologies, you wouldn't want, if you've got devices on your network you don't want to have people to have access to, you probably want to put some security on your network. Once they're in the network, Fling is about an architecture of open communication within that network. And we fundamentally realized that the TV was being treated as this island, that was separate from the rest of our digital lifestyle. And we wanted to close the gap. And this is one way to do this, is to sort of implement an open architecture for communication back and forth, from the TV back out to the web, and from the web back to the TV. So that's the second part of our presentation, actually. Does that answer your question? Yeah, sure. As long as it's supported by the hardware. So there's some codec limitations on most devices. It turns out that those codec limitations are now sort of converging with most web video. For example, most of the embedded processors don't decode VP6 encoded content in hardware. So the playback would be very choppy. But if that video is encoded in H.264, the video would play back pretty well. And thanks to some efforts that Adobe's made and others on the web video market, at Apple, for example, most web video and video online is moving to a format that's actually hardware accelerated in most of the TVs today. Not currently. I think that's also something that's not widely supported today. We think that'll change. Apple and other companies, some of the TV app platforms, for example, are starting to support HLS in their network stack. That will ultimately become an interesting additional set of content, but by no means mainstream yet. So assuming you're the developer of a secured website that has secured video, you could include Fling behind a paywall. That's something that you could do as a developer. Currently, what we've done in the open source realm is to enable this for web video that's not secured. You can take the tools that Dave was talking about, all of the code that's on flingo.org, and implement that behind your registration or authentication mechanism. Yeah, sure. Yeah, sure. Do you want to take it?
We're making an assumption that is very applicable in the United States and in most countries, and that is that users have a NAT in their home. Okay? It could be a Wi-Fi. It's combined with most Wi-Fi routers. If you're using a cable modem, you probably have a NAT sitting right next to it. Okay? And as a result, all the devices in your home go to the outside world through a single IP address. So it doesn't require that I use broadcast or multicast to say that two people are on the same network. A third party sitting out on a server can just look at a request coming in and say, hey, that has the same public IP as this other TV does. And then it would tell whoever's using our APIs, web pages that are using our APIs, these are the devices that are in your network. In fact, the building block that I gave there with a link was was just an example of a very simple integration. There are more APIs that allow you to exactly identify specific devices and services. Yeah, you can. In this example here, it didn't select. It just sends to all. But you can pass arguments. You can find devices and pass arguments to say which one. Okay. That's sure.
Currently, there's two ways that this is getting implemented. Manufacturers either have a queue at the platform level that you can fling to, and there would be some disclosure that you could use Fling to support to do that. There's a couple of platforms we know that are going to do it that way, Vizio, potentially Boxy in the future. Then there's an app also in the App Store that we've submitted to LG, to Samsung, and a few other platforms called FlingQ, and that's when you fling video, it would end up in that application. All right, I'm going to switch gears here to another really exciting platform technology that we built, and that's basically creating a reverse loop on this context. We've demonstrated how the user can send the smart TV some metadata from the web, video that you want to watch. There's also this really other interesting communication loop, which is how does the web get smarter about the things you like on TV? And it turns out that in spite of everyone's best efforts in the over-the-top market, whether you're Netflix or Hulu or YouTube or the apps that we've created, that still represents a fairly small fraction of what people do with their smart TVs. It turns out that broadcast TV is the killer app. People watch a lot of TV. According to Nielsen, that's about 5.5 hours of our day, whether it's prime time or daytime, sports, all the content out there is very valuable not only to the industry, but it's very valuable to consumers. And so what we felt would make a smart TV even smarter is to be able to algorithmically identify what's on the screen. So we call this framework to do this SyncApps. SyncApps uses a video fingerprinting algorithm in the chipset of the TV to identify what's on screen. We use a process that's very sort of designed for this purpose. It's not something we designed for fingerprinting through your cell phone the way Shazam or other applications do it. We designed a specific platform and algorithm that works within the constraints of a TV chipset and uses video signals to do this because that's the richest form of signal in the TV. We can identify content much faster than if we were using just audio to do that. We're now fingerprinting most of the content in the US, and we'll be extending that to North America throughout Q1, and we look forward to kind of fingerprinting broadcast networks around the world throughout 2012. What can you do with that? TV manufacturers have an app store and apps that are completely divergent, completely orthogonal with broadcast TV. But with this technology in the smart TV, those applications can start to dovetail with the broadcast experience. So a lot of Americans watch American Idol. I believe it's still the #1 rated show. To participate in that show, you have to text in your favorite contestant. It's really interesting if you could use the smart TV to actually participate in that show. So we are showing here an example of what you can do while watching American Idol. Simply with your TV remote, you vote on your favorite contestant. We also think about how that context gets emanated out into your local area network, the reverse of what we showed you earlier. And so we believe that the smart TV should enable a web server. We've actually put that in our software stack that allows any device around the network to ask the TV, what's on screen. And this is something that we're going to show you how to build. We've got a number of mobile app developers that are using some of our APIs to basically get this signal and get this information from the TV. It really makes the smart TV kind of the center of your entertainment experience. And by doing it in the center, doing it in the TV, you don't need to search or do anything sort of kludgy with any of these other devices, because those devices automatically know what's there. So I think that for applications like American Idol, for stats when you're watching sports, for advertisers that want to extend the reach of the broadcast ad model, we think this is going to be a really, really important technology for the smart TV market. We think this is the sort of the nexus of bringing the smart TV market to a much, much bigger opportunity around broadcast. I'd like to show you a couple things. This is what we're showing in our booth over at the Venetian. We'd be happy to have any of you over to show you this. But basically, what you see on this TV behind Dave is some live linear programming. We're fingerprinting this programming in real time. Once we've identified it, we've enabled a social TV framework. Do you have the remote, Dave? Okay. So basically, what will happen here is that if I interact with the sync apps layer that's running on top of the TV signal, we've not only identified the content, but we've associated the content with a Facebook and a Twitter page. So I can very easily socialize with one click of the TV remote what I'm watching. And we think this is something that is going to be a really powerful example of ACR technology in the TV. It's the missing piece to make social TV available to a lot more people, because the experience for social TV today, we believe, is pretty broken. If I want to tweet about the show that I'm watching, I don't know what the official hashtag or Twitter account is for all the TV shows that I like to watch. But with this framework, we can actually pre-populate that in the TV and very easily evangelize to our friends what we're watching, and it's tweeted immediately, right from the TV. Any questions about that? Yeah, please. ACR, yeah. So ACR stands for Automatic Content Recognition. It's becoming sort of industry jargon. There's different approaches to ACR. I'll just explain a few. Some folks believe that watermarks, built into the TV signal are a good way to figure out what's on screen. Some people are using audio signals in their cell phone. We're using video signals inside the TV, and we do this only for the smart TV market. We're not participating in any of those other approaches. Yes, please. We'll have some announcements about that in the future. Yes, please. So we've ported this algorithm to pretty much every TV SoC out there. So if you're a TV manufacturer, chances are that you could call your silicon supplier and ask for this, ask for the Flingo ACR solution, and they might already have it ported and ready to go. We've announced a couple manufacturers in addition to the SoCs. The Walmart private label products, Sanyo brand has this. The Best Buy private label products, the Insignia brand has this, and we'll have some more announcements in the future. Yes, please. The point is you don't need to. We've already done that with the software. And the applications that you use can ask our software what's on the screen. And it's running in the sort of the operating system of the TV persistently. So it's basically fingerprinting, analyzing, and then providing that data back to the user and saying, do you want to tell your friends about it? Do you want to provide it to another application developer? It's basically putting the user in control of that metadata. Does it make sense? Mm-hmm. Yeah, it's a good question. So we can identify content with just a few frames of video, and it's very rapid. So we're seeing, including the process to identify the content, to communicate that to our database and return it back to the TV, that's usually less than 3 seconds. Yeah. Yes, please. If we've indexed it, we've got some metadata about it. So that's correct. So this is 100% real time. Yeah, it's a great question. Yeah, so we don't need to know what CNN, the news is going to be today. We're actually fingerprinting CNN at this moment. And so as you're watching it, we can return that metadata back to you. Yeah, that's actually an easier problem, right? Any archived content. No, it does, in fact. It does work with live TV. It's built for live broadcast TV. So we're basically creating this database in real time so that you, as you're watching live TV, you'd be able to query that database. Yeah. That's correct. Yeah. It absolutely works with sports. Sports is going to be a really fun application of this technology. Yeah. Yes, please. It's an interesting question. Right now, that's not the application we're currently focused on. If you're a video search company and you'd like to, basically query this API, we'd be happy to support you. Yeah, it's not the problem we're trying to solve. Yeah. Well, we're very focused on the smart TV market. What is the thing that makes smart TV really exciting for the consumer, for the manufacturer, and for the broadcaster? And so really it's not taking people away from broadcast, it's making broadcast better and using the software to basically improve the economics for everyone involved. Sure, one more. You want to do that in your example?
I was going to, but it's not going to work with this network setup.
Okay, well, we're not going to do a live demo just because of the network issues, but what I'm going to do is turn it over to Dave. And for any of you who have a website, a mobile app, a TV app that you'd like to contextualize with live TV, we're going to show you the API and how you could go about doing that and what you would get back, what metadata you'd get back. Okay, we'll go quick.
I think there's probably not any time at all. Here, give it to me. I have an example online you can check out that is just this simple. It's essentially a hello world that just says what's currently running on a TV. And if you come by our booth, I can actually walk you through this tutorial if you wanted it. But the tutorial is available online with all the APIs on how it's done. And I'd like to point one thing out. This is a web page. If you're talking, as opposed to an application, a web page is very constrained to a security sandbox. But yet it can find the TV and talk to it. So you can imagine an example of I go to Amazon.com and on their homepage could be the products that were just advertised on the TV. Okay? Or I could go to IMDb and it could show me on its homepage the metadata for what I'm watching on television. Okay? This is the URL of where the API, the tutorial source code is located. Any questions? Yeah, I think we're out of time.